Find the number of terms of the geometric series 1 plus 4 plus 16 up to 67,108,864, and then calculate the sum of this series. Right, so we need to find the number of terms in the series, i.e. what the term number is that. Now, a geometric series is that they are multiplied by the same amount. So 1 times 4 gives you 4, 4 times 4 gives you 16, and then so on. You can find the common ratio by just taking the second term and dividing it by the first term, or any two consecutive terms. So that's 4 divided by 1, which actually gives me 4. Now, any term of a geometric series is given by un is equal to the first term times the common ratio to the power of n minus 1. So we're going to have 67,108,864 is equal to the first term, which is 1, times 4 to the power of n minus 1. Now, because this is 1, we could just say that 67,108,864 is equal to 4 to the n minus 1. Now, because the unknown is in the power, we need to take logs to any base, but normally we would take base 10 or natural logarithms. So that will give me that log of 67,108,864 is equal to log of 4 to the power of n minus 1. Now, the rule of logarithm says that you can now bring down the power in front of the log. So log of 67,108,864 will be equal to n minus 1 log 4. Rearranging that, you're going to get that n is log of 67,108,864 divided by log 4 plus 1. And that will give that n is 14 terms. This would have to come out to be a positive integer. Right, the sum of the geometric progression can be found by Sn is a to the r to the n minus 1 over r to the minus 1. And because r is bigger than 1, it's better to write it this way round. So the sum of the first 14 terms will be the first term, which is 1, times 4 to the 14 minus 1 over 4 minus 1. That gives me 4 to the 14 minus 1 divided by 3, which will give me 89,478,485. So this has been a video for you to show you how to find the number of terms in a geometric progression and the sum of the given geometric progression. I hope you've understood, and I thank you very much for watching.